Hi friends. So today's challenge is we have to implement a singly sided connected linked list, like the single linked list. So what do you think? How much time would it take? I believe we can do it in 5 minutes. So pause the video and then come back once you implement it. So I believe you tried it. Now let me show you my version of code. So first thing, we have the test cases to back up that we are on the right track. So we have now in linked list, basically the nodes are connected. So first thing you need is a class which is called as node, and you can apply generics or not, like whatever you want. So it would take the next node's object reference. So initially it would be null. Even if you don't define, it would take null by default. Second thing is the data, which is most important thing, which it would take. And then if you want, you can have a public constructor which would get the data and assign it as soon as you would create the node. So you would say this dot data is equal to whatever you pass in the constructor. So we are all set with the singly linked list. We have a single reference for the next node, whatever is the adjacent node. Now let's start coding. So we need to create the method here. So here we should have the first node's reference, like whatever is your first node. From that, each node is knowing only about the upcoming node. So what's the first node? You need to save it here first. So when you do the add method, so and then as you know that in linked list there are two directions, from the front and the back. Like in any list there is a entry and the exit, or the front and the back, right? So this you can either add from top, or like from front or back. So we are trying to add and remove from the first in this singly linked list. Then we would see how to do it in the upcoming video in doubly linked list chapter, or the challenge. Right now we need to add. So how do you do that? So you need to pass as an argument whatever element you want to add. Now you need to check if your first element is empty or not. So what you can say, you would say node n is equal to first. So you would get the first node. Now you check if n is equal to null, which means your first node is equal to null. Whatever element you are creating, that would get added here, right? So now you might need to create the element as well. So we would do node, new node is equal to new, sorry, I wrote nope, and you can pass the value. So now since we have implemented the generics, when we create it, we can define what kind of object we want, right? So let's say this is a string. So I would say first. So our first, whatever thing, we can just tell it as that it's a string thing. Same thing, we might have to apply generics here. If you don't know about it, just don't worry, but I'll cover it in the upcoming videos, so keep a watch on that. Now what it means is you can either add integer or string. So once you have that, so if your n node, which if your first node is actually null, so you can add whatever is the node here at the first place. But if it is not null, then what you would do? Then you have to replace your first node with this, and then you might need to put the next node there. So how do we code this? This is super simple. So your first node will become the new node, and your new node dot next element might become your first node. This is what would happen. So understand here that if your first node is null, then your first node would be replaced by the new node. So first node, new node, and then the new node's next would be your first node, and first node could be anything here. Actually, we can remove this line also to make it simple. So if your first node is equal to null, or no matter, like even we don't need to check it if it is null or not null, that's fine. So what we would do actually here, that we create a node and then we reference the current first node as the next node of the new node, and then the first node would point to the next node, and that's all. So let's see if this is going great. But to test, we also need to make sure that we have a method to check. So we would say boolean is empty, and this method would tell us if whether or not. Let's do it like this to make it faster. So we have this method here. So if the linked list hasn't been started, which means its first node would be null, which means it is empty. So if it is not null, then our test case are supposed to pass. Yay. Now, since this passed, now we will try to remove the node. So removing would be almost similar. We might need to do few checks for the null. So we will remove from the front, remove. So whatever is the first element, we need to remove that, and no need to pass anything here. Whatever would be there would be returned. So now we would say node is equal to whatever the first is referring. Now since you're removing it, so your current and dot next, so imagine like this. So you have the first node, after that you have the second node. So second node is supposed to come at the first node. So first node's reference would be gone. So second node would be the whatever is the first dot next. Whatever is that, that would become the first, right? So the reference would be like this. And then whatever, so you took the object reference before, or first before changing it. So you can remove, you can return the first node, and you might need to apply casting because of generics. Now what is happening here is you're changing over the node. So your first node would be returned. What if your first node is null? Then this guy will give you the null pointer exception. So that is why you need to check if your first node is not null. If this first node is not null, then you would do this. Otherwise, if your first node is null, then you can just return null. And can we cast null with E? That's a question, interesting question to try. We can try that. So let's first try this happy case, then when we experiment with that. So if this thing works fine, let's do a dry run. You have the first reference. If it's not null, then you're forwarding. Okay, seems, let's see. So there is some issue on line number 48. First, second, first. So what we did here is, so we had the first, and then, so the problem is like we hard coded this value E, which is supposed to be an argument. So once we do this and run our tests again, this would be passed. So this is what happened here. Basically, let me rerun it. So we are all set. So we just implemented a single linked list. Now we would look at double linked list as part of second coding challenge. So be ready, guys. Thanks for watching.